Okay, today's topic is compound events, and the essential question is, can you answer probability questions that involve compound events? The definition of compound events is this right here. Okay, and compound events deal with a combination of simple events where two or more outcomes are desired simultaneously. Okay, and simultaneously means at the same time, so you need two things to occur at the same time. When you need two outcomes to happen at the same time, which means simultaneously, you must multiply the chances of each outcome together to get the probability of both happening simultaneously. So you're going to look for the keyword and, or something that means and I'll explain that more later. So when you see that keyword and, you're going to multiply the probabilities of them together, all right? And we'll go right into an example. Okay, if you roll two dice, what's the probability of rolling a 2 on one and a 4 on the other? Okay, and I'm going to show you how challenging that could possibly be. I want 2 and a 4. Not 2 or 4, I want 2 and a 4. So I'm doing this experimentally just to kind of show you how the odds of that happening are very, pretty, it'll take me a while to get there basically. So the odds are kind of low to do that the very first time you roll. I want 2 and a 4. Oh, there we go. Okay, so that took me quite a few times, and since the probabilities of that happening when you have an and problem, it's really hard to have that happen the first time. We're going to multiply those events together. Okay, we're going to multiply each of those probabilities together. So here's how you'd write it out: probability of getting a 2 and a 4. That would be the probability of getting a 2 is 1 out of 6, and we're going to multiply because we see the word and the probability of getting a 4 is 1 out of 6. Okay, 1 out of 6. So 6 times 6 is 136, which is 0.02, and repeating the 7, which is approximately 2.8%. So if I were to roll this like one time, the chances of me landing just like that are only 2.8% to get a 2 and a 4. Now, let me show you just a different kind of problem. If I wanted a 2 or a 4, do you think that would be more likely to happen or less likely to happen, to get a 2 or a 4? Let me show you. Look, I already did it. There's a 4, okay? So the chances of that happening the first time are more likely than this happening. So on a separate note, the probability of getting a 2 or a 4 would look like this. Probability of getting a 2 is 1/6. I'm going to add them instead of multiply. Probability of getting a 4 is 1/6. So the chances of getting a 2 or a 4 is 2/6. Okay? And let me double check here. Okay. And that right there is 0.3 repeating, which is approximately 33.3%. So see how the chances of that happening, a 2 or a 4, are higher than the chances of getting a 2 and a 4? For your summary, I want to know, why is the probability of landing on a 2 or a 4 higher than the probability of landing on a 2 and a 4? We learned about counting trees, or also known as tree diagrams, yesterday in class. And I want to show you how you can solve these and type problems using that. So Natalie's parents promised to buy her a vehicle. However, they told her that she must spin each spinner one time to determine what type of vehicle she'll get and its color. Okay? So it says draw a counting tree to display all the possible combinations. So we're going to start with start. And on that first spin, and remember with theoretical probability, you're always going to assume that it's never going to land on the line, okay? Because I know when in experimental probability, if you spin it, sometimes it does land on the line, and that kind of messes you up maybe. But we're going to assume in a theoretical probability, it's never going to land on the line. So we're going to start, and you can either land on, I'm going to use the first letter for each vehicle, so I don't have to write it all out. So sports car, Jeep, truck, or a minivan, okay? And I got a little sloppy there, I'm sorry. So this first column, I'm going to write it just about the top because I ran out of room. I'm going to call that the first spin, okay? And then the second spin, the possibilities that she can land on are blue or red. So if she landed on sports car first, the second spin she can land on blue or she can land on red. If she landed on the Jeep first in the first spinner, she can land on blue and red on the second spinner. The truck first, she can land on blue or red on the second one, and same for here with the minivan. These are called independent events because whatever happened here doesn't determine what's going to happen here, okay? They're both independent of each other. Okay, and we're going to label that column the second spin, and I'll label it on the top because I ran out of room. I don't want to mess up that next problem. Second spin. Okay, now comes the part where we're going to go ahead and write out the outcomes. So a sports car, that's blue. I'm just going to write blue sports car. Right here, a sports car, that's red, so I'll just write red sports car. Right here would be a blue Jeep, red Jeep, blue truck, red truck, blue minivan. Sorry about my spelling, I'm writing kind of fast. And right here would be a red minivan. And we're going to label that column as there's 8 possible outcomes. Okay. So using the counting tree, you can figure out the probability that she'll get a red Jeep. So look up here, how many red Jeeps do you see? Right there, red Jeep, there's one of them out of the 8. So the probability of getting a red Jeep is 1 out of 8, which is 125 thousandths, which is also 12.5%. Okay, now let me show you how to use the strategy that I showed you on the front page. That's not the front page. On the front page, right here, see how we multiply? And I don't see the word and in here, but I see something that means and. It says, what's the probability she'll get a red Jeep? Right here, it's going to be red and it's going to be a Jeep. So in the notes, when I said look for the keyword and or something that means and, that's implying and. You want red and a Jeep, red Jeep, okay? So here's how you could do it the other way without using a counting tree. Probability of getting red and having it be a Jeep, okay? So all you do is find the probability of it being red. Probability of getting red is 1/2. And in probability means multiply. Now the probability of getting a Jeep is 1/4. And multiply straight across. So 1 times 1 is 1, 2 times 4 is 8. So you see you get the exact same answer as if you would have used a counting tree. So if you're more comfortable with the counting tree, then go ahead and do that to help you come to your answer. If not, you can do it this way also. All right? Okay, what's the probability that she will not get a blue minivan? So one way you can do this is just by looking up at your counting tree. I see that that's not a blue minivan, that's not a blue minivan, that's not a blue minivan, that's not. Oh, there it is, and that's not. So all the ones that are not blue minivans, that totals up to 7 out of the 8. To do that mathematically without a counting tree, I knew that there was going to be 8 possible outcomes to figure this out. So the grand total of possible outcomes would be 8/8. Or if you're like, I don't know all the total possible outcomes, you can just say 1, because 8 divided by 8 is 1. And you're going to subtract the probability of getting a blue minivan. Well, for her to get a blue minivan, it's 1 out of 8. You because you want blue and minivan. 1 minus 1/8 is 7/8. Or you could say 8/8 minus 1/8 is 7/8. Okay? So you take your total possible outcomes and you subtract the probability of getting a blue minivan. And that's how we get 7/8. Go ahead and turn the page. You've decided you want a plant for your room. At the gardening store, there's 4 different kinds of plants: tulip, fern, cactus, and ivy, and there's 4 different kinds of containers to hold the plants. There's clay pot, plastic pot, metal pot, and wood pot. If you randomly pick the plant and the pot, what's the probability that you'll end up with a tulip in a plastic pot? Okay, this is one of those ones where you got to assume it means and. You want a tulip and a plastic pot. Okay, so this is an and problem. So we're looking for the probability of getting a tulip and a plastic pot. Okay, so the probability of getting a tulip, there's only 1 tulip out of the 4 possible plants, so your probability is 1/4. And in probability would mean multiply, and the probability of getting a plastic pot is 1 out of the 4 possible types of containers. So 1/4 times 1/4 is 1/16, which is 0.0625, which is 6 and 25/100%. Okay, if you just want to keep it like that, that's completely fine. I just want to show you, I like to give you repetitions on this just because it helps with your memory. 1 divided by 16 equals this. To turn this into a percentage, you multiply it by 100 and you get this, okay? So it's good just for you to have that repetition in case you need to access that someday. The more you see it, the more you'll remember it. Okay, if you flip 3 coins, what's the probability that you'll get a tail on the first flip, a head on the second flip, and another tail on the third flip? This is another and problem. You want a tail and a head and a tail. Okay, so the probability of just landing on tails is 1/2. And means multiply. Probability of landing on heads is 1/2. And means multiply in probability. And probability of tails right there. Okay, so 1/2 times 1/2 times 1/2 is 1/8, which is 0.125 or 12.5%. You could have also totally done a counting tree. It might have taken a little bit longer, and if you didn't have enough room, you could do it on a separate sheet of paper. But that would be completely fine also. If you're curious about doing that, you can look at yesterday's notes, because we do a problem where we are flipping a coin, I think just twice though, or maybe 3 times, I can't remember. Okay, for your summary, when you see the word and only in probability, what should you do with each event's probability? Here's a hint. What did we do? We see the word and in probability. So Elijah loves to go to Baskin Robbins to meet his friends for ice cream. But he was late, so they ordered for him. They told him he either had a waffle cone or a sundae. So a sundae would be like in one of those plastic bowls. Okay, so a waffle cone is like a cone that's made out of like waffle material, I guess. And a sundae would just be in a bowl, okay? And the ice cream flavor was either vanilla, strawberry, chocolate, or bubblegum. What's the probability he will get strawberry ice cream in a waffle cone? Well, you could totally do a counting tree for this one, similar to what we did on that second problem. But I'm just going to go ahead and show you the fast way, all right? Either way will work. So the probability of getting strawberry. And, because it's in a waffle cone, we're implying that it means and waffle cone. Okay, so the probability of him getting strawberry, well, there's only 1 strawberry out of the 4 possibilities, so it's 1/4. And would mean multiply. The probability of getting a waffle cone, it's either a waffle cone or a sundae, so it's 1/2. 1/4 times 1/2 is 1/8. And these are the other forms that would be acceptable. What's the probability he will get a chocolate sundae or a vanilla sundae? I see there's an or problem right here, but this part makes it a little bit more lengthy. Okay, we got to figure out the probability he'll get a chocolate and a sundae. Okay, so the probability of him getting chocolate was 1/4 and means times. Probability of getting a sundae is 1/2. 1/4 times 1/2 is 1/8. Okay, so the probability of him getting a chocolate sundae is 1/8. Okay, the probability of him getting a vanilla sundae. So we want probability of vanilla and sundae. So probability of getting vanilla, again, it's going to also be 1/4 times probability of getting a sundae is 1/2, so that's 1/8. Okay. So when you see or, so probably get him getting a sundae, a chocolate sundae or a vanilla sundae, you want to add those two probabilities together. You want to take your 1/8 from the chocolate sundae and add it to the 1/8 from the vanilla sundae, and that would give you 2/8 or 25/100ths or 25% chance of either of those happening. And if you did a counting tree, you would also have that same probability. I'm just going to go ahead and take a second and show you the counting tree. If I can fit it. So we're starting out with start. And they told him it was either on a sundae or a waffle cone. And I'm abbreviating, okay? And then they told them if, okay, that's our first one. First, let's see, container, I guess. Okay, and then they said you could either have vanilla, strawberry, chocolate, or bubblegum. Okay, vanilla, strawberry, chocolate, or bubblegum. And that's going to be the flavor. Okay, so we could have a vanilla sundae. We could have a strawberry sundae. We could have a chocolate sundae. We could have a, bubblegum sundae. Okay, we could have a vanilla waffle, strawberry waffle, chocolate waffle, bubblegum waffle. So in that particular problem, what's the probability he'll get a chocolate sundae or a vanilla sundae? I see a chocolate sundae, and I see a, where's the vanilla? Oh, vanilla sundae. Okay, and how many possibilities were there? There's 1, 2, 3, 4, 5, 6, 7, 8. So 2 out of the 8 would be the vanilla sundae or chocolate sundae, which simplifies down to 1/4, which simplifies down to 0.25, which also equals 25%, which is exactly what we got right here. Okay? So when in doubt, you can always do one of these counting trees. And I'm sorry, I didn't really accurately label this. I want you to put a column around it and label it 8 possible outcomes. I'm sorry, I ran out of room. Okay? All right, what's the probability he will not get bubblegum ice cream in a waffle cone? So if you already had this made, you can probably see it pretty easily. But I'm going to show you how to do it without that. If you want to, you could rewind the video and figure it out using the counting tree. But what I would do is all the possibilities would be 1 whole, or 8/8 because there was 8 possible outcomes. Now I'm going to subtract the probability of him getting bubblegum and a waffle, because it's bubblegum in a waffle cone. Okay, so first off, that's all together. So the probability of him getting bubblegum was 1/4, right? Let's see, 1/4? Bubblegum. Yeah, 1/4. And probability of him getting waffle is 1/2. So it's 1 minus that, okay? So 1 minus 1/4 times 1/2 is 1/8. So 1 minus 1/8 is 7/8. Okay? So that right here is the probability of him getting, or of him not getting a bubblegum ice cream in a waffle cone. If you look right here, where's bubblegum ice cream in a waffle cone? Bubblegum in a waffle right there. It's 1 out of the 8 possibilities. So all the ones that are not bubblegum in waffle cone is 7 out of the 8. Okay. Okay. Try the next page on your own. Pause the video. A spinner with 2 equal portions, red and green, is spun 2 times. What's the probability of the spinner landing on red both times? You could do a counting tree if you want. So, but we really want red and red. So probability of getting red is 1/2. Probability of getting red again is 1/2. So you have 1/4 chance, or 25/100ths, or 25%. Okay. If you did a counting tree, it would just look like this. And you can get red, green on the first spin. And then red, green, red, green on the second spin. And so this will be red, 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 green, green, red, green, green. So the probability of getting red both times is 1 out of 4, just like what we got here. Okay, if a dice is rolled and a coin is tossed, what's the probability of getting head and a 6? So we want probability of head and 6. So probability of getting a head is 1/2. Probability of getting a 6 on a 6-sided dice is 1/6. So that's 1/12, which is 0.08 with the 3 repeating, which is approximately 8.3%. And number 7, if you flip a coin and spin a spinner that has 6 equal sections labeled 1 through 6, what's the probability of landing on heads and the spinner landing on a 5? So we want probability of heads and 5. Okay. Probability of landing on heads is 1/2, multiply. Probability of getting a 5 on a spinner labeled 1 through 6 is 1/6. So your answer is 1/12, which is really 0.08 with a 3 repeating, which is approximately 8.3%. Okay? All right, when you see the word or in probability, what should you do with each event's probability? I'm going to give you a hint. It's not multiply, because when you see the word and only in probability, you'll multiply the events together, okay? But when you see the word or, what should you do to them? So if this said probability of landing on heads or 5, what should you do instead of multiply if it said or?